Hi everyone, in this video I am going to solve O-Levels Additional Mathematics Paper 2 in a session May-June 2024 Paper 2-2. So let's start with the first question. Question number 1 part A, on the axis sketch the graph of this function stating the intercepts with the coordinate axis. So first we have to find out the intercepts basically. So as you can see, this is a cubic function, right? Its power is 3 and the graph of cubic function extend from first to third quadrant or second to fourth quadrant depending upon the sign of the leading coefficient. So let me write this in the form y equals to 2x minus 5 x plus 3, and you have to convert this into x minus 1, taking minus 1 common. My negative sign is common, so this negative sign is common and this is the leading coefficient. So when the leading coefficient is negative, it means your graph extends from second to fourth quadrant. All right, now let me find out the zeros. Right, so x-intercepts, we have to put the variable y equals to 0 and solve for x. When this y is 0, it means this whole term equals to 0 and we have 3 x-intercepts. We can say 2x minus 5 equals to 0. So x from here is 5 by 2. Alright, and what is 5 by 2 in terms of decimal? This is 2.5. 2.5. The next one is x plus 3 equals to 0, and from here x equals to negative of 3. The last one is x minus 1 equals to 0, so x is equals to 1. So x equals to 1, 2.5 and negative 3 are the x-intercepts. Let me work on the y-intercept. Y-intercept, you have to put the variable x equals to 0 and solve for y. So y is equals to, this x is 0, 0 and 0. We have negative is outside, it's minus 5 plus 3 and minus 1. Okay, so negative times negative is positive and this is negative, and 3 times 5 is negative of 15 is my y-intercept. Now let me sketch the graph by stating the intercepts. Right. Okay, 1 2 3, minus 1 minus 2 minus 3, negative 3 is my x-intercept, 1 is my x-intercept and 2.5 is my x-intercept. These are the x-intercepts. All right, and the y-intercept downward is negative 15. Okay, 1 2 3, let's say this is minus 15, this is 5 10 15, right? Okay, now let me sketch the graph from second to fourth quadrant. Why it is from second to fourth? Because the leading coefficient is negative. It is positive, then it extends from the first to the third quadrant. All right, so let me do this. It starts from here. Okay, okay, so that would be the shape of the graph. Right, now moving to the second part B, hence number 1, solve the inequality when this is less than equals to 0. So look at the graph, this would be the function y. So when we have to find when y is less than equals to 0, here y is less than equals to 0 on what values of x? When the x values are between minus 3 and 1, the y values are less than equals to 0, and when x values are more than 2.5, it is less than equals to 0, right? So we can say minus 3 is less than equals to x is less than equals to 1, and x is greater than equals to 2.5. The y values are equals to 0 and less than 0. Now for second part of B, on the axis below, sketch the graph of this function. So this is the same cubic function, but this is an absolute form. So when we have an absolute, it means the x-intercept stays the same, which is negative 3, 1 and 2.5, right? X equals to 1, 2.5 and -3. These are the x-intercept. But now the y-intercept, this is an absolute. So absolute y-intercept we have over here is negative of 15. Now absolute of negative 15, this would be equals to 15. The y-intercept is positive. The x-intercept stays the same, but now the y-intercept is on the top. So let me sketch this one. All right, so we have 1, 2, 3, and over here we can say this is 1, 2, 3, 1, -1, -2, -3. All right, if say this is -3, this is 15, this is 1, this is 2.5. All right, the x and the y intercepts. All right, now the shape is the same, but now you have to move the y-intercept on the top, right? Okay, again the same you have over here, and from this point you have to move up, and the graph passes from the y-intercept. Let me make it more clear. Just the rough sketch I'm doing. Okay, it crosses the y-intercept and then this x-intercept. We're not moving down. Another x-intercept and this. So because it's in an absolute, so it always lies at the top, like when y is positive, not the negative ones. So this would be the shape of the graph. Question number 2, part A, evaluate this. You must show all your working. So this is the integral. The integration of cos of something is sine of x. Okay, so this integration is sine of x by 4, and the derivative divides the derivative of x by 4 is 1 by 4, and the definite integral from pi by 3 to pi by 2. So this is 4 sine of x by 4 from pi by 3 to pi by 2. Let me substitute the limits. 4 sine x is pi by 2 over 4, the upper limit, minus 4 sine x is pi by 3 over 4, the lower limit. All right, so this is 4 sine pi over 2 times 4 is 8, minus 4 sine pi over 3 times 4 would be 12, right? Let me simplify. This is in radians. Okay, so sine pi by 8 times by 4 is, and minus 4 times sine pi by 12. This is 0.495. 0.495. This is the answer. Now for part B, we have to find this. So simplify the integration. So the first integral is 1 over 4x minus 3 dx, splitting the integral, plus the second integral is 1 over x cube into dx. Okay, so 1 over x is basically ln of x. So here 1 over 4x minus 3. So when the derivative is complete in the numerator, we can apply the ln x formula. So its derivative of the denominator is 4. So multiply and dividing by 4. Over here I'm dividing and over here I'm multiplying. So 4x minus 3 and dx. And over here we have to apply the power rule. So shift the x cube into the numerator with the power negative of 3. Right, so this is 1 by 4. So since the derivative of the denominator is present into the numerator, so we can say this is ln of 4x minus 3, this integration. And applying the power rule, x to the power minus 3 plus 1 divides minus 3 plus 1 plus some constant of integration I'm going to add, because this is not a definite integral, this is an indefinite integral. All right, okay. Further simplification, we have 1 over 4 ln of 4x minus 3 plus x to the power minus 2 over minus 2 plus some constant of integration. Or for the simplification, we have 1 by 4 ln of 4x minus 3 minus 1 by 2 x square plus c. Question number 3, part A. Determine whether the equation has two distinct real roots, two equal roots, or no real roots. Okay, so it means we have to make a quadratic equation and solve the discriminant. Okay, so let me simplify. So simplify the numerator first. 4x times 3x. So 4 times 3 would be 12 and x times x would be x square. 4x times 2. 4 times 2 is 8. So 8x. 1 is multiplying with 3x and 2. So this is 3x plus 2. And over here, x plus 1 is multiplying with the cross multiplication I'm doing, 5x minus 3. This is 12x square, 8, 9, 10, 11 plus 11x plus 2. This is x is multiplying first, so this is 5x square minus 3x plus 5x minus 3. Shifting all the terms to the left side, so 12x square with minus 5x square plus 11x is over here. So what is this? 5 and negative 3. 5 and minus 3 would be 2x. So shifting the 2x on the other side becomes minus 2x. And plus 2 is over here, and this would be plus 3 equals to 0. So from 12 take away 5, this would be 7x square. And from 11 take away 2, this is 9x. And plus 5, this is equals to 0. Now this is a quadratic equation. To find out the roots, whether they are two distinct roots, two equal roots, or no real roots, we have to solve the discriminant. And what is the discriminant? Discriminant is b square minus 4ac. So let me simplify the discriminant. B value is 9. It's 9 square minus 4 times a value is 7 and the c value is 5. Alright, now we have 9 square is 81. Okay. 4 times 7 times 5, this would be minus 140. From 81 subtract 140, this is minus 59. Negative of 59. Since the discriminant is less than 0, it is negative, so it means it has no real roots. When it is equals to 0, it has two equal roots. When it is positive, it has two distinct real roots. Since the discriminant is negative, so it has no real roots. Now moving to the B part of number 3, solve the equation. Alright, so we can say 12 over cube root of x, okay, minus, let me make the same denominator, cube root of x over cube root of x. I'm multiplying and dividing by cube root of x, so it's square, and this is equals to 4. All right, so this is going to be 12 minus, what is cube root of x square? We can keep it as it is, cube root of x, its whole square, divides cube root of x, and this would be equals to 4. Now let me do the cross multiplication. 12 minus cube root of x whole square, and shifting the equals to 4 into cube root of x. Now shifting this term over here, this would be negative of cube root x. Okay, this is 12 minus and its whole square, and minus 4 cube root of x equals to 0. To make it simple, let me suppose that t is equals to cube root of x. Okay. So this is 12 minus t square minus 4t. This is equals to 0. This is a quadratic equation and a variable t. Let me take negative sign common. So this would be t square plus 4t minus 12 equals to 0. Right. Now this looks like a quadratic equation and a variable t. Alright, now we can factorize it or apply the quadratic formula. 1 times 12 is 12. The factors of 12, that makes 4. 2 times 6 is 12, and 6 minus 2 is 4. So 2 square t square plus 6t minus 2t minus 12 equals to 0. So this is t is common, we are left with t plus 6. Negative 2 is common, we have t plus 6 equals to 0. So the factors are t plus 6 and t minus 2 equals to 0. Alright. So further I'm gonna do over here. we can say t plus 6 equals to 0, and from here t minus 2 equals to 0. So the t value is negative 6 and here t value is positive 2. Now put it back. What is t? T value is cube root of x. This is equals to negative 6, and cube root of x, this is equals to 2, right? So we have to solve for x, not the cube root of x. Okay, so cube root of x is basically x to the power 1 by 3. This is minus 6, and x to the power 1 by 3 is equals to 2. So how can I solve for x? So you have to take the cubic power on both sides. So x to the power 1 by 3, its cube, equals to minus 6 whole cube. X to the power 1 by 3, its cube, equals to 2 to the power 3, right? So this is x and 6 to the power 3. Okay, so this is minus 6 times minus 6 times minus 6. This is 216 with negative. And here x is 2 cube is 8. So we have two solution, 8 and minus 100, minus 216. Question number 4. The polynomial p is such that p of x we have given. Number A, find the remainder when p of x is divided by x minus 2. If it is divided by x minus 2 equals to 0, so this is x would be equals to 2. So we have to solve for what is p of 2 and find out the remainder. 6 into 2 cube plus 2 square minus 12 into 2 and plus 5. Okay. So 2 cube is 8. 6 times 8 is 48. 2 square is 4. Minus 12 times 2 is 24. And plus 5. Now simplify. 48 plus 4 minus 24 plus 5. This is 33. So the remainder is 33. Now for part B, number 1, show that 2x minus 1 is a factor of p of x. Okay, so again we can say 2x minus 1 equals to 0. So what is x? X is 1 by 2. We have to solve. If it is a factor, it means p of 1 by 2 should be equals to 0. Let's see. P of 1 by 2, let me simplify. This would be p 6 1 by 2 whole cube plus 1 by 2 whole square minus 12 into 1 by 2 plus 5. Simplify, we can say 1 cube is 1, 2 cube is 8, and 6 by 8 in simplest form is 3 by 4. This is 1 square is 1, 2 square is 4, and this is 2 times 1 is 2, 2 times 6 is 12, negative 6 and positive 5. Simplify, we have 3 by 4 plus 1 by 4, negative 6, positive 5. This would be equals to 0. So this is proved. It is shown that 2x minus 1 is a factor of p of x. Now for second part of B, hence write p of x as a product of linear factors. So we have given that 2x minus 1 is a factor. Let me apply the method of syntactic division over here. Okay, and let me write this down. Okay, now write down the coefficient of the polynomial p of x. Okay, x cube coefficient, x square coefficient, x coefficient, and the constant term. And this is 1 by 2, right? 1 by 2. We have to bring the 6 as it is down. 1 by 2 times by 6. We can say 1 by 2 times by 6 is 3. And 1 plus 3 would be 4. Now 1 by 2 times by 4, this would be 2, and when you add them up, this is negative 10. And 1 by 2 times minus 10, this is negative 5, and when we add them up, this would be equals to 0. So now these are the coefficients of the quadratic. It is reduced. Syntactic division reduced the equation to the one less power. Now it's a cubic one. Now applying syntactic division, it is going to be a quadratic. Now the polynomial p of x, we can write this down as x minus 1 by 2 is the factor. We have 6x square plus 4x and minus 10. All right. Now let me rearrange this form as a product of linear factors. Okay, so we have to write down 3 linear factors over here. All right, so further simplification, we have p of x, we have 2x minus 1 divided by 2. This is equals to, let me take 2 common as well. We have 2 times 3 would be 6, 2 times 2 is 4, and 2 times 5 is 10. So this 2 and this 2 is cancel out, so p of x is going to be 2x minus 1 into 3x square plus 2x minus 5. All right, so 3 times 5 is 15, right? So we have to find the factors that make 2 for 15. All right, we can say 5 minus 3 would be 2. So p of x over here, this is, okay, let me just solve this term. This is 3x square plus 5x minus 3x and minus 5. 3 times 5 is 15, right? So let me take x common. We have 3x plus 5, and negative 1 common. We have 3x plus 5. So the factors are x minus 1 and 3x plus 5. And this is the third one. So the product of linear factor, the polynomial p of x, is going to be 2x minus 1, 3x plus 5, and x minus 1. So these are the 3 linear factors. Now for the third part, hence solve the equation for x theta is between 0 degree to 90 degree. So this equation is 6 sine cube theta plus sine square theta minus 12 sine theta plus 5 equals to 0. This is the same polynomial. Now x is replacing with sine theta over here. All right, so if I can say, let's say x is replacing with sine theta, we have the same polynomial, the same one, right? So if we have 6x cube plus x square minus 12x plus 5, this is equals to 0. As you can see, this is a polynomial, so it means polynomial should be equals to 0. It means this is a polynomial. It means 2x minus 1, 3x plus 5, and x minus 1, this is equals to 0. So from here again, let me replace x with sine theta. So we can say 2 sine theta minus 1 equals to 0. And from here, what is sine theta? Sine theta is 1 by 2. Let me solve for theta. Theta is going to be sine inverse of 1 by 2. What is sine inverse of 1 by 2? It should be in degrees. Okay, it is in degrees now. Sine inverse 1 by 2 is 30 degree. So theta is 30 degree, right? The next one I'm gonna do is 3 sine theta plus 5 equals to 0. So from here, sine theta is negative 5 over 3. So theta is sine inverse of 5 over 3. Let me solve for the positive. We are not getting any solution from this equation because sine is positive in first and second quadrant, and 0 to 90 degree is just the first quadrant. Here sine is negative, so we are not getting no solution from here because sine, we can say sine is positive in first and second quadrant. Since the domain we already have given from 0 to 90, just the first quadrant, so we will get solution. This is negative, so this answer should be in the form of in the third and fourth quadrant. So third, fourth quadrant is not given in the range of the question. The next is sine theta minus 1 equals to 0. So from here, what is sine theta equals to 1, and theta is sine inverse of 1 is 90 degree. Theta is 90 degree. So we can use 90 because we have equality over here. So from 0 to 90, the two answers are 30 degree and 90 degree. Question number 5. A curve has equation this. The tangent to the curve at a point where x is equals to 1. When x is 1, so we can say when x is equals to 1, what is the y value? So y is going to be 5e to the power of 2 minus 1 plus e. So this is 5e to the power 1 plus e. So 5e and 1e, this would be equals to 6e. So the point is 1 and 6e. X is 1 and the y is 6e. It cuts the x-axis at point P. So first we have to find out the equation of tangent. Find the equation of tangent in the form y equals to mx plus c, where m and c are exact values, and hence find the x coordinate of P. So for equation of tangent, what we need? We need the derivative dy over dx at x is equals to 1. Alright, so 5, the derivative of e to the power x is e to the power 2x minus 1, and the derivative of 2x minus 1 is 2, and e to the power 1 is stays the same. The derivative is just e. No, e to the power 1 is a constant number, so its derivative is 0. Sorry, constant's derivative are 0. Yes. So this is 10 e to the power of 2x minus 1. Now let me solve dy over dx at x is equals to 1. So this is 10 e to the power 2 minus 1. So this is 10 e is the derivative, right? Now let me write down the equation of tangent, which is y minus y naught equals to m into x minus x naught. That is the equation of tangent. Y minus y naught is 6e, m is 10e, and x minus x naught is 1. We have to convert this into y equals to mx plus c form. So the y minus 6e, this would be equals to 10ex minus 10e, and y would be equals to 10ex minus 10e and plus 6e, right? So from here y equals to 10e and x and negative of 4e. Now this is in the form of y equals to mx plus c. This is mx and c is negative 4e, right? Okay, now we have to find the x coordinate of P. So what is x coordinate of P? We have given that the tangent cuts the x-axis at point P. So when it cuts the x-axis, it means y should be equals to 0, right? When it is cutting the x-axis, it means y is equals to 0, and we have to find the x component. So 0 equals to 10ex minus 4e. We can say 4e, this is equals to 10ex. E is cancelled with e, 4 over 10. This is x, and 2 times 2 is 4, 2 times 5 is 10. So we can say the x coordinate of P is 2 by 5, or in decimals we can say 0.4. X coordinate of P is 2 by 5 or 0.4. Question number 6, part A, show that this can be written in the form sine square x and tan x. Okay, so let's start. We have sine cube x. Cosecant is 1 over sine x. And 1 over cot is basically tangent, and tangent is 1 over cot x. Okay, so this is sine cube x into 1 over sine x. 1 over cot is sine x over cos x. Sine this square and this is cancelled. We are just left with sine square x times sine x over cos x is tan x. So this is proved that this is sine square x tan x. Now for the second part B, solve the equation for x is between minus pi to plus pi. Alright, and this is cot square x tan x 1 by 2 tan x equals to 0. Let me simplify this first. We have cos square x, tan is sine x over cos x, minus half Tan is again sine over cos. This is equals to 0. Okay, so we can take cos as an LCM, or we can say, or you can take sine x over cos x common, or tan x is common. So let me take tan x common, and we are left with cos square x and minus 1 by 2. This is equals to 0. So both factors are separately equals to 0. It means tan of x equals to 0, and cos square x minus 1 by 2, this is equals to 0. So x is equals to tangent inverse of 0, right? So this is in radians. Okay, my calculator is in radians now because this is in pi, so it is radians. So tangent inverse of 0 is 0. Now this equation says tangent is positive. We have to check in which quadrant tangent is positive and in which quadrant it is negative. So let me draw the cast rule and explain you the situation. So this is a cast rule, C, A, S and T. Here we have theta, we have pi minus theta, pi plus theta, we have 2 pi minus theta. Now tangent is positive in the first quadrant and in the third quadrant, right? So one value of x is 0, the other value of x is going to be pi plus that x. So it is pi. So it should be between minus pi to plus pi, not equals to pi. So it means this value is not including into our answer because on pi there is no equality on the pi, right? Now let me solve the second one. So we have done with the first one. Now the second one is, from here we have cos square of x is positive 1 by 2, and taking the square root we have cos x square root of 1 is 1 over root 2. X is going to be cos inverse of 1 over root 2. Let me simplify this. Cos inverse, okay, cos inverse of 1 divides root 2, pi by 4. So x is equals to pi by 4. Again, here the cos is positive in this equation. Cos is positive in the first quadrant when all is positive, and in the fourth quadrant when cos is positive. So it is 2 pi minus pi by 4. So x is going to be 2 pi minus pi by 4. Right, 2 pi minus answer. This is 7 pi by 4. Okay, what is 7 pi by 4 is 5.49 pi. 7 by 4. Okay, what is 7 by 4? 1.75 pi. So 1.75 pi, as you can see, it is not in our answer. So this is pi by 4, and what is 1 by 4? 0.25 pi. This belongs over here. From minus 1 pi to plus 1 pi is 0.24 pi. This is the solution, but this is not the solution because 7 by 4 is 1.75 pi. We need the answer till 1 pi or minus 1 pi. So this is not the solution, right? So the one solution is 0, the other is pi by 4. And there is another solution. When we are doing square root on both sides, this become positive and negative. We have done with a positive one. Let me solve for the negative one as well. So for negative one, if I can do over here, we can say cos of x is minus 1 over root 2. Alright, so again x is going to be cos inverse of 1 over root 2 with a positive 1, and here x is pi by 4, right? Now check in which quadrant cos is negative, in the second and in the third quadrant. So pi minus pi by 4, pi plus pi by 4, these are the two solutions. So x is pi minus pi by 4, or x is pi plus pi by 4. All right, so this is 4 over here, and 4 minus 1 is 3 pi by 4, and over here 5 pi by 4, right? So let me check what is 3 by 4. That is 0.75 pi. Yes, that is a solution because we need the answer between minus 1 to plus 1 pi. And what is 5 by 4? This is more. So this is not the solution. So we can say the only solution we have is x is equals to 0. We have pi by 4. And we have 3 pi by 4. These are the two solutions. Question number 7. Find the number of different ways the 9 letters of the word polymaths can be arranged when. So the total number of letters are 9. Number A, the O and A are not next to each other. O and A are not next to each other. All right. So first thing first, we have given that polymaths can be arranged. There are 9 letter words, so polymaths can be arranged in 9 factorial ways, right? P O L Y M A T H S. This can be arranged in 9 factorial ways, right? So what is 9 factorial? Let me simplify. 9 factorial, this is 362,880. 9 factorial is 362,880. Okay, now when we are considering O and A as one unit, so we can say OA is a 1 unit, and we have the rest is P, L, Y, M, T, H, and S. So how many? 1, 2, 3, 4, 5, 6, 7, 8. This can be arranged in 8 factorial ways, because there are 8 letters now. So let me solve for 8 factorial. So 8 factorial is 40320. 40320. That is 8 factorial. All right. Okay, and we can say we can write OA as AO. All right, this implies there is another 8 factorial ways, right? So we can say OAPLYMTHS, or we have AOPLYMTHS. So there is another 8 factorial ways. So it means there are 40320 ways again, right? Okay, so now we can say when O and A are next to each other, when O and A are next to each other, OA or AO. So how many total ways? We have 40320 plus 40320. 8 factorial plus 8 factorial, 2 times of 8 factorial. This is 8,640 ways we can arrange, right? Now the question is OA are not next to each other. When OA are not next to each other, it means from total number of ways, which are 9 factorial, we have to subtract when OA are next to each other. Next to each other. All right, so let me solve this. So total are 362,880. Subtract this one, 80640. All right, 3622880. Subtract answer. This is 282240. 282240. So these are the number of ways when O and A are not next to each other. Let me explain you one more time. So whenever you have a such type of question, first you have to find the total number of ways that word is going to arrange. Since this word has 9 letters, so it is going to arrange 9 factorial ways. All right, that would be the total. Now when O and A are next to each other, so when you're considering OA as a single unit, O and A as a single unit, we have 8 factorial ways, and there is another method when AO is a single unit, there is another 8 factorial ways. So add the 8 factorial with 8 factorial, or 2 times of 8 factorial. So these are the number of ways when OA or AO are next to each other. Now we have, from the total, we have to subtract when they are next to each other to get when they are not next to each other. Now moving to B part, the letter maths are arranged in this order. All right. So you have to arrange M, A, T, H, S. This is as a one unit because they are together in this order. This is going to be together in this order, and the rest of the unit words or letters are left at 0. Sorry, P, O, L, and Y. So how many letters we are considering? 1, 2, 3, 4, and 5. We can say this can be arranged in 5 factorial ways. So what is 5 factorial? Which is 120. So the answer is 120, because the letter M, A, T, H, S are together in this order. They said in this order, so we are not replacing the orders. We can do, but if in the question it is not saying that in this order, this word is not using, so we have to make a but over here you can see OA, AO. We have 2 possibilities. Now we have 1, 2, 3, 4, 5 letters, so we have 5 factorial possibilities, right? So they're saying the letter maths are together in this order, the same order, so we are not changing that order of MATHS. So rest of the letters are POLY, so there are 5 factorial ways because we can arrange it in 5 ways. Question number 8, an experiment was carried out and the values of y for certain values of x were recorded. The table shows the values recorded. The relationship between y and x are modeled by this equation where a and k are constants. Number 8, draw the straight line graph for L and y against x. Okay, the straight line graph for ln y against x. So means x stays the same. We have to find what is ln of y. ln 10, ln 13, ln 22, and so on. So ln of 10 is 2.3. ln 13 is 2.6, rounded. ln 22 is 3.1. The next is ln 35 is 3.6, and ln 50 is 3.9. All right. So 15 and 2.3. 15, this is 2, 2.1, 2, and 3. For 30, 2.6. 30, this is 2.5 and 2.6. For 45, it is 3.1. 45, it is 3.1. The next is 60, 3.6. 60, we have 3, 3.5, and 3.6. The last is 75 and 3.9. 75, and this would be 4, and this is 3.9. So connect all the points, that would be the straight line graph. Now for the part B, find the equation of line in part A and hence find the values of A and K. Give each value correct to one significant figure. So first we have to find the equation of line in part A. And this is a part A, we have to find this equation of line. Okay, so we have x and ln of y. So we can take the 2 points to find out the slope first. So let's take 15, 2.3 and 30, 2.6. So what would be the slope? The slope is the m value, which is y2 minus y1, y2 minus y1 over x2 minus x1. Then we have the coordinates 15, we have 2.3, and corresponding to 30 we have 2.6. So these are x1, y1, x2, y2. Okay, so 2.6 minus 2.3 over 30 minus 15. All right, let me find this out. 2.6 minus 2.3, this is 0.3. 30 minus 15, 0.3 divides answer 0.02. This would be the slope. So the equation would be y equals to mx plus c. So substitute any point to solve for c. Let's take the point 15 and the 2.3. 2.3, this is ln of y, sorry, and this is equals to 0.02, x is 15 and plus c. So 2.3 minus 15 times 0.02, this is 0.3 and equal plus c. Okay, 2.3 minus 0.3, this is equals to 2. Okay, 2 is the value for c. Okay, now we have the equation of line. This is ln of y equals to 0.02x plus 2. Okay, so it, all right, now this is equation of line in part A, and hence find the values of a and k. So let me solve the value of a and k. This equation we have given is y equals to a e to the power kx. Let me rewrite. Y equals to a e to the power of kx. Applying ln on both sides, ln of y equals to ln of a e to the power kx. Okay, so in the product we can do the ln with the plus. So ln of y equals to ln of a plus ln e to the power of kx. Ln of y equals to ln a, ln and e is cancelled, so we have just kx. So now this is in the form of ln of y equals to kx plus ln of a. So we can say we have, this is ln of y, compare it, k value 0.02, right, and ln of a value is equals to 2. We have to solve the value of a and the value of k, not ln of a. When we are comparing, we come to know that ln of y kx 0.02x, and from here k value is 0.02, and from here ln of a, this is equals to 2. And what is a? So a is e to the power of 2. Let me write this down. E to the power of 2 is 7.4, we can say 7.4 a, or a, we have to write the answer up to one significant figure. So one significant figure is just 7. So a value is 7 and the k value is 0.02. That is the one significant figure. Now for part C, find the value of x for which y equals to 17. So we have equation ln of y equals to 0.02x plus 2. All right, we have to solve for ln of, okay, x, ln of 17 equals to 0.02x plus 2. So this is ln of 17 subtract 2, this would be 0.02x, and ln of 17 subtract 2 divides 0.02, this is going to be the x. Okay, let me just simplify the value of x. Ln 17 minus 2 divide 0.02, 41.67 is the x value. Question number 9, the diagram shows the part of the curve. This is a quadratic curve. The diagram shows the part of this curve and the line AB. The curve and the line AB. This curve and the line AB meets the x-axis at A. So means it has some x and the y should be equals to 0. And meets again at a point B, which is 5 and 12. The line CD extended. CD, this is extended, is parallel to y-axis and passes through the maximum point of the curve. It passes through the maximum point of the curve. Find the area of the shaded region. So first let me find out the coordinate of A. Okay, so this curve, the coordinate of A, coordinates of the point A we are working on, right? So since the curve and the line meets at point A, at x-axis at point A. So when x-axis, it means the y component is 0 throughout the equation. So means 32x minus 4x square minus 48. This should be equals to 0. Okay. Okay, let me divide by 4. 32 divide by 4 is 8x minus x square minus 12 equals to 0. Now let's take negative sign common. X square minus 8x plus 12, this is equals to 0. Now let me factorize this to find the two factors. 1 times 12 is 12, 2 times 6 is 12, and minus 2 minus 6 is minus 8. X square minus 2x minus 6x plus 12, this is equals to 0. X is common, x minus 2 is left, negative 6 is common, x minus 2 is left, equals to 0. So the two factors are x minus 2 and x minus 6. This is equals to 0. So we have the 2x value is 2 and x value is 6. So let's see which x coordinate is for A. So as you can see, the B coordinate over here, we can say this point is 5. Here x is 5. So means this x should be less than 5, right? So it shouldn't be 6, it can be 2. So the A coordinates are 2, 0 and the B coordinate are 5 and 12, right? Now let me find out the equation of line AB. The next point, we are working on equation of line AB. So for equation of line AB, we have A is 2, 0 and B is 5, 12. We need the slope and the y-intercept, right? So the slope value is y2 minus y1 over x2 minus x1. So this is 12 over 3. That would be equals to 4. That is the slope, right? Now in the next step, we have to find the equation of line by using y minus y naught equals to m into x minus x naught method. Okay, or we can say the line is y equals to mx plus c, and to get the c value, we have to use the 0.20. Let me use x is to y. 0, 0 would be equals to 4 times 2 plus c. So 0 would be equals to 8 plus c, and from here c value is negative of 8. And we can say the equation of line AB is y equals to 4x minus 8. That is the equation of line AB. Okay, line AB. Okay, now we need the maximum point as well, because it passes through the maximum point of the curve. It is a quadratic equation. To find the maximum point, we can find out the vertex basically. So let me convert the standard form of the quadratic to the vertex form. All right. So this would be the arranged one. X square minus 8x plus 12. I'm working on it. Okay, so here I'm finding the maximum point. Maximum point of the vertex, maximum point of the parabola is the vertex point basically. Okay, so we have an equation x square minus 8x plus 12. This is equals to 0. I want to convert this standard form to vertex form to find out the vertex. That would be the maximum point. So x square minus 8x and plus 12 equals to 0. Then x square minus 8x. Now take negative 8 divided by 2. This is minus 4 and take it square. This would be 16. So add and subtract 16 inside the bracket. So every time when you're converting the standard form to vertex form, in many comments the student asks me the question that why I'm dividing by 2 and what's going on over here. So let me explain you the method that every time when you are converting the standard to vertex form, the first step is you have to take the coefficient of x square, which is 1. You have to take that coefficient. If it is 2, 3 or any number other than 1, you have to take it common from the first term and the second term. So 1 is common, so it means these two terms stay the same. That would be the first step. And in the next step, whatever the coefficient of x, if it is negative 8 or any number, you take that number and every time you have to divide it by 2, right? This is a rule, right? Okay, now you will get some number and take it square, so you will get answer that would be 16. Now add and subtract that number inside the bracket. The next step, you have to combine the first 3 terms and the last term is as it is. Take it outside the bracket. 1 times minus 16 would be minus 16. Okay, so this is x minus 4 its whole square, right? And 16 and 12, this is negative of 4 equals to 0, right? So that is the factored form of the quadratic equation, which is a into x minus h whole square plus k equals to 0. That is a factored form. Okay, so the factor is h and k are the factors, and over here h value is 4 and the k is negative 4. That would be the factor. So the vertex. So for the maximum point, we need the x component only. So we can say the maximum point is, this would be the maximum point, the x component of the vertex. 4 is the maximum point. So over here, the c, this would be 4. This is the 4, right? Now the question is, now we have everything. We have the point A, we have the point B, we have the curve, we have the equation of line, and we have the maximum point. Now we have to find the area of the shaded region. So this is the shaded region. The shaded region is between x equals to 2 and x is equals to 4. So first we have the curve and then we have a line. So integration of the curve between 2 to 4 minus integration of the line from 2 to 4. That would be the area of the shaded region. Let me write this down. So we can say area of the shaded region. So area of shaded region, this is going to be, we can say, area integration from 2 to 4 of the curve. The curve is 32x minus 4x square minus 48 dx, and minus integration of line from 2 to 4, and the line is 4x minus 8 dx. That would be the area. Let me simplify. So 32x integration is x square over 2 minus 4x square integration is x cube over 3 minus 48 and x. This is from 2 to 4. And negative, this would be 4x square by 2 minus 8x, and this is again from 2 to 4. Further simplification we have over here is 16x square minus 4 by 3x cube and minus 48x. This is from 2 to 4, and minus this is 2x square minus 8x. This is from again 2 to 4. Let me substitute the limits, the upper and the lower ones. Okay, and find out the area. Let me do this over here. So we have area, this is going to be 16. The upper limit is 4, its square, minus 4 by 3. We have 4 cube minus 48. We have 4. This is the upper limit. Subtract the lower limit is 16. We have 2 square minus 4 by 3. We have 2 cube and minus 48 times 2. All right, minus this is 2 and upper limit is 4 square minus 8 into 4. Okay, subtract the lower limit. So subtract and subtract becomes positive. Why I'm doing upper limit minus lower limit? Because it is positive. Now it is negative. So this is the upper limit and minus lower limit. So minus and that minus becomes positive. 2 into 2 square minus 8 into 2. This. Okay. Now let me simplify the area. Okay, so 4 square is 16. 16 times 16 is 256. Okay, now 4 cube times 4 divided by 3. This is 256 over 3 minus 256 divided by 3, and minus 48 times by 4 is 192. Okay, subtract 2 square is 4. 16 times 4 is 64. Minus 4 times 2 cube is 8 divided by 3, which is 32 out of 3, and minus 48 times 2, this is 96. Okay, now subtract 4 square is 16. 2 times of 16 is 32. Okay, and 4 times of 8 is also 32, minus 32. This becomes 0. Now 2 cube, 2 square and 2 cube would be 8 plus. This is 8 minus 8 times 2 would be 16. Now let me simplify this. We have 256 minus 256 divided by 3 and minus 192. This is minus 64 over 3. 64 divided by 3. All right. Next bracket, let me solve. We have 64 minus 32 divides 3 and minus 96 only. Minus 126 over 3 and this minus becomes plus. So plus 128 over 3. This is minus 0 and we have minus 8 minus 16 becomes negative of 8. Okay, now we have 128 over 3 minus 64 over 3 and minus 8. This is 40 over 3. That would be the area of the shaded region, 40 by 3 units, or we can say 13.33. 13.33 units. Question number 10, the function f and f of g are defined by, we have f of x and f g of x. Number A, explain why f inverse exists. Why f inverse? We have given f, why the inverse of f exists. So there are some conditions when f inverse exists. The first condition is f inverse exists because f is one-to-one function. One-to-one function means it satisfies horizontal line test. Right, because as you can see, this is exponential function, so it must satisfy the horizontal line test. And the third condition we have is it has restricted domain. When the domain of the function is restricted, it means its inverse must exist. X is less than 0, the values that are less than 0. So these are the three conditions: that function must be one-to-one, it must satisfy the horizontal line test, and it must have a restricted domain. If these conditions are valid, or any one of the condition is valid, then f inverse of that function exists. Now moving to part B, find an expression for f inverse and state its domain and range of f inverse. Okay, so we have y equals to f of x, e to the power x square plus 3. Now replacing the variables, we can say x is equals to e to the power y square plus 3. Okay, now solve for y. Okay, let me apply the ln. Yes, on both sides. Ln of x equals y square plus 3 and ln of e. Ln of e is just 1. Ln of x equals to y square plus 3. Solving for y, we can say ln of x minus 3, this would be y square, or we can say y is equals to, we can take plus minus square root of ln of x minus 3. This is the y. Okay, so we can take plus or minus. So let's see. We know that the domain of f of x is equals to the range of f inverse of x, right? So the domain of f of x is less than 0. That would be the range of f inverse of x, right? So from here we can say the range of f inverse of x is f inverse is less than 0. Now let me work on the domain of f inverse. The domain of f inverse of x is the range of f of x. So what is the range of this f of x? Let me solve the range of f of x. So for the range x is less than 0, if I put x equals to 0, it means e to the power 0 square minus, this is e power 3, right? Okay, and I'm working for the range, so we can say f of x is less than equals to e to the power 3 or greater than equals to, when x is 0 and it is less than 0. So for less than 0 we have minus 1, minus 2, minus 3. If we can take negative as well, it becomes positive. So e to the power 3, e to the power of 3 is this. And what is okay, e to the power 3 is 20.1, we can say, and e to the power of 4, it is more. Yes, it is greater, we can say. So f of x is greater than e x cube. So this would be, we can say, x is greater than e cube, right? That is the domain and range. Now for f inverse, we can take positive or negative. So the domain is x is greater than e to the power of 3, and the range is f inverse is less than 0. I guess domain range are clear. Now for f inverse of x, we have to take it negative. Why? Because they said x is less than 0, the values that are less than 0. So we are taking it negative of ln of x minus 3. That would be the f inverse of x. Now for part C, hence find and simplify an expression for g of x. We have given that f g of x, this is e to the power 2x. So what is g of x? G of x is going to be f inverse of e to the power 2x, right? So what is g of x? G of x is negative square root ln e to the power 2x. X is replacing with e to the power 2x minus 3. That is my g of x, or ln and e is just 1. So g of x is negative square root 2x minus 3. This is the function g of x. Question number 11. In the binomial expansion of this number, the first three terms in increasing powers of x are this. Find the values of the constants n, a, and b. Let me open the first three terms in the increasing powers of x. Okay, so we have the first term is 2 to the power n plus nc1 2 to the power of n minus 1, and we have x over 2 plus nc2 2 to the power of n minus 2, and x by 2, its power is 2, and so on. I just opened the first three terms in the increasing powers of x. Okay, let me simplify these terms. Okay, this is already in the simplest form. So let me put them equal to b plus abx plus 9 over 8 ab x square. We have to find the values of n, a, and b. All right, so let's do the comparison. The comparison, we can say comparing coefficients. Alright, so when I'm comparing the coefficients, we have the constant with the constant. So we can say the comparison of constant. First we are doing. So the constant is 2 to the power n, and this is equals to b. This is my first equation. Comparison of x. X is nc1 2 to the power of n minus 1, 1 over 2. This is ab. This is my second equation because I'm just working with the coefficient of x and with the x, right? The third is the coefficient of x square, which is this. So we have nc2 2 to the power of n minus 2, 1 over 4, we can say, because 2 squared is 4 and x square coefficient, and this is equals to 9 by 8 ab. This is my third equation. All right. Okay, so from equation 2 and 3, let me arrange the equation 3 first. Okay, so from here, what is equation 2? I'm working on equation 2. nc1 2 to the power of n minus 1, and here 2 to the power of minus 1. Shifting the 2 into the numerator, this would be ab. Alright, so nc1 2 to the power of n minus 2. When bases are same, we can add the powers. N minus 1, and minus 2, this would be my ab. Or we can say nc1 is my ab over 2 to the power of n minus 2. Let's say this is equation star. Okay, and arrange the third equation as well. nc2 times 1 by 4 and shifting this term on the other side, it becomes 8 over 9, the reciprocal. This would be my AB, and dividing this term on the other side, 2 to the power of n minus 2. This is another equation, star prime. So you can compare the star and the star prime. Okay, compare equation star and star prime. So we can say NC1, this is equals to NC2. 4 times 2 would be 8 into 2 by 9. I just compare NC with this equation and this equation, so this side and this side. Okay, and let me open the formula of the factorial. NC1 is n factorial over 1 factorial n minus 1 factorial, and this is n factorial over 2 factorial into n minus 2 factorial, multiply 2 by 9. Alright, so now n factorial is cancelled out with n factorial. 2 factorial is just 2, so 2 is cancelled out with this 2. Now let's do the cross multiplication. We have n minus 2 whole factorial over n minus 1 factorial. This is 1 by 9. Let me simplify this further. We have n minus 2 factorial is as it is, and we can open this n minus 1 and n minus 2 factorial. This is 1 by 9. So n minus 2 factorial is cancelled out, so we can say 1 over n minus 1, this is 1 over 9. So we can do reciprocal on both sides or doing cross multiplication. So 1 n minus 1 would be 9, so n would be equals to 9 plus 1, that is equals to 10. So we got the value of n, this is equals to 10. This is the n value. Now let me solve the value of a and the value of b. Alright, so from equation 1 we can say equation 1 we have is 2 to the power n equals to b. So 2 to the power n, this is my b. So 2 power 10 is the b, right? Let me simplify what is 2 to the power 10. So 2 exponent 10 is 1024. So we can say b over here is 1024. We got the value of b as well. Now let me work on the a value. All right. Okay, you can substitute into the first, second or third equation. I'm working with the second equation. The second equation says NC1 2 to the power of n minus 2. This is equals to AB. All right. So what is n? N is 10. So we can say 10C1 2 to the power of 10 minus 2 is 8 times 1 over the B. B is 1024. This would be my A. All right. So 10C1 is 10. Okay, this is 10 times 2 to the power of 8 is 256, and times 1 over 1024. This is my A. 10 times 256 divides 1024. This is 5 by 2 is my A value, 2.5. A is 5 by 2. This is 2.5. So we got the values of the constants A, B and N. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.